BSides San Antonio. Once again, I want to give a quick shout out to our platinum sponsors, Island and St. Mary's, for helping to make the event possible. And we're also grateful for the support of Alamo ISSA and Black Hills. And I'm going to turn the mic over to Dwayne McDaniel as he discusses from pets to cattle to agents. So join me and welcome Dwayne.
Telenovela is the name of that band, other band. I don't know why my brain went blank there. They're a little band from Texas. Thanks so much for having me. I am super happy to be here. Highly, highly, highly recommend grabbing the slides from that tiny URL because I talk fast and I have a lot of slides. And with that, I'll give you a chance to take the picture, maybe go to it, and we'll go. This is a mouse. This is a Western deer mouse. This is a mouse. Are these the same mouse? Maybe. Does it matter? I don't know identity. And this is a mouse. This is the second time today this mouse has been referenced. Does anybody know this mouse? The context clues, that's not from the original book illustrations, but there's the dodo, there's Alice. Yes, this is the mouse with the sad long tail. And this is a mouse. Now, of all these mice, one of them, for some reason, we believe can drive a steamboat. I didn't know that the actual image for anthropomorphification or anthropomorphism in Wikipedia was literally that mouse until I was making these slides and I had gotten to, hey, I need to get the definition and looked it up. And then I was like, oh wow, I'm onto something here. Because at the core of this talk is this concept of anthropomorphism. Anthropomorphism. We can't help we do it. This is an innate thing in our brains. We assign human characteristics to other things. This is not personification. This is not that storm system Alice. No, this is a thing that we have assigned human traits to. There's a good side and a bad side of this. I'm going to talk about the good side today, but I do want to acknowledge the work of Wendy Nather, who gave a wonderful keynote up in Halifax at the Atlantic Security Conference this year on toxic anthropomorphism. Meaning we're treating things that aren't human as human and trusting them as if they're human. And I think that's bad. So does she. And I agree with her. But there's a value that we can derive from this anthropomorphism. The fact that we can't help but assign human characteristics to things that aren't human. And that's what this talk is about. That weird thing down in the right, bottom right, that is my interpretation of what agentic AI is. It's ChatGPT with a wallet and a computer. I give a whole other talk about that, but that's not really what I'm going to get into today, the meat of that, but we'll touch to that later. But the premise of this talk is if we shouldn't give that thing in the lower right standing privilege and the ability to just do things without humans in the loop, without some kind of way to hold it accountable, then maybe we shouldn't have done that with anything else on this picture because these are all the same thing. We just anthropomorphized it. This is the same picture as that, at least in my brain. By the way, I'm Dwayne. I come from Chicago. This is, I think, my 19th talk this year. I love San Antonio so much. I was at a hardcore show last night. You have a really cool metalcore show and scene in this town, if you're not familiar. Really, really heavy, loud music with kids like going crazy in the pit. Saw Eye of the Beholder last night. Check them out. They're local. They are so good live. They're so good live. But I help people figure stuff out. That is my entire mission. So if I can help you figure something out today, I have done my job, but I've also fulfilled my purpose. You can visit my website to see my upcoming tour dates and classic, or all the places I have spoken and all the links to all the blog posts I've written about it. I write blog posts about everywhere I go, almost everywhere I go. And mostly on social media, I'm on LinkedIn because at least it's honest. Like, it is what it is, and it's never tried to be anything more or fool me into believing it's anything other than just business people talking to business people. So talk to business people, or talk to me over there about business stuff. Git Guardian will come up later. I have stickers up here about them, but we help people solve the entire problem of secrets visibility. All right. Brief history of DevOps. Because I bet at some point, somebody in the audience is like, wasn't they supposed to talk about pets? Yeah, I am. I'm getting to it, I promise. Once upon a time, there was one computer, ENIAC. It was huge, it filled rooms, literal rooms. When we debugged it, it had literal bugs in it. That's where the name bug comes from, like little moths. I think at one point, Topper said that the original moth was preserved in a cabinet in the Office of Navy Intelligence, but she hadn't seen it in years, so she wasn't sure it was still there. Back in those days, it was very easy to think about security model. You either got into the room or you didn't. And it was easy to stop people because you were the Navy and you had guns and you had locks. And the thing that you were trying to preserve was the availability of the machine being there and physically be there, the integrity of the operations in that room, and the confidentiality, because ENIAC was used for war purposes. That's where the CIA triad comes from, this world. Fast forward in time a little bit, and we get to 12 computers. We hooked them up together and we called it ARPANET. And the first 2 characters ever sent between 2 of those machines broke the whole damn thing. That's a true fact. But then it started working good enough that college kids could stay up late. There's a great book called Where Wizards Stay Up Late that documents the entire history of this. But those kids started playing Zork and Space Command. And these are machines that cost $300 an hour to run. So they said, how do we stop that from happening? Well, let's hold them accountable, and we'll hold them accountable by making sure that they log in and they give them a username and password. Still lock the door. They still shouldn't be on campus if they're not a student. But this is where our modern idea of I am using some kind of authentication token to prove I should be here really comes from. Stopping kids playing Zork. Of course, this is a very short version of DevOps history, so bear with me. Oh, I keep hitting the wrong button, sorry. Back in those days, I make a lot of book references. If you ever read The Cuckoo's Egg, read The Cuckoo's Egg. All right, I'll give you the right way moving forward. All right, back in those days, it was very simple in the operations side of the world. You keep the thing running. That is the mission. Very simple. This is the era of pets. Because these servers, these big honking machines we put things on, were called CERN-1. Then we called them Zeus. I was having a conversation with a buddy of mine in New York. The first server he set up was Teltran 3, because Teltran 1 was the one in Transformers. So his was Teltran 3. Teltran 2 was like in the comic books, but Teltran 3 was the one we hit. That's still, I still think Teltran, the child of Teltran 3 runs today. That's where it runs its Plex server. But it's a named thing. We keep it alive. How do we keep it alive? We patch it. We make sure that it gets everything it needs. We make sure it's nurtured and loved. And that gave us semantic versioning. This is where this concept comes from. It's like we are going to put out a version of something that we can run reliably at scale over time, no matter what shame version is running at the end. Then we get from 12 machines to millions of machines, or hundreds of thousands of machines to millions of machines. And hey, there's CERN-1. That's the world's first web server. It's still in CERN, where Tim Berners-Lee wrote the very first very ugly web application. We would call a web application. Fast forward a little bit in time, and people realized, wait a minute, if we're going to be using these small machines to write small bits of incremental software, we can't do it the way that they used to write that big honking machine stuff. We can't do waterfall anymore. Now, today we just do waterfall really fast and we don't do agile, but there was a dream at one point to do agile. Down is the Agile Manifesto. That's the whole thing, by the way. That's it. If you read it instead of listening to me, good job, because that's what you're supposed to have done, because I ramble. But that's it. Simple, straightforward. It was around this time that we realized, why are we have this stupid wall between the people that write this stuff and the people that run this stuff? What if we slam them together and call it DevOps? Now, this wasn't any one particular person say, we're going to do this heads or top down. This was the community that said, no, this is how it needs to work because we're too slow otherwise. We need a way to iterate faster, because that's what DevOps really is. DevOps is not tools. Anybody that says DevOps is tools is trying to sell you a DevOps tool. Anybody that says DevOps is about platforms is trying to sell you a platform. DevOps is about shortening the communication feedback loop to the people that can make a change. That's it. however fast you can make that iteration loop happen, the better your DevOps is. That's what DevOps was supposed to be. We got so good at it that we wrote it down. If you haven't read these books, highly recommend it. I make a ton of book recommendations, but start with the Phoenix Project and then move to the DevOps Handbook, not the other way around. Otherwise, you will never get to the Phoenix Project, I promise you. But they both say very, 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 very critical things. Thanks to the work of all the authors. Well, around this time, we realized, wait a minute, why do we have to run one-to-one? Why do we have to have one physical machine on one physical machine? Why do we have one logical machine on one physical machine? Well, we don't. We invented the hypervisor. And this is where I come into the picture. This is literally where I enter the world of software. I'm an old Java middleware guy. Like, I came into the picture after we figured out JVMs could be a thing, and we could just run dozens of them on big pieces of iron, and then eventually hundreds of them, and then eventually thousands of them on giant pieces of iron. And at this point, our pet analogy breaks down. Because now we don't have one hunting dog, we have an army of hunting dogs. It's still managed, it's still ours, it's still something we need to take care of. But if one of them dies, I'll be a little sad, but the pack's gonna keep going. It needs to be managed. But then we realized, hey, we don't need to own the infrastructure. What if we just rented someone else's computer and then we called it cloud? And it confused the entire world. Instead of saying rented computer, we said cloud computing, and the world lost its mind for about a decade. And we went from building things like this. This is Drupal 6, where I started with Drupal back in the day when I was a developer. And we built monolithic things that ran as one logical giant stack of thing that ran. And we started building applications that tie together third-party services. Some estimates I saw, modern software being developed is 98% tying together other existing software. And all the logic building is just doing that little tiny layer of you. Everything else is dependencies down. This gets us to the world of supply chain security, which I am not going to talk about deeply today, but understand this caused the nightmare we're living in with Shai-Hulud, Team PCP, and all the nonsense that's going on in the NPM and PyPy ecosystems right now. If you don't know what that means, talk to me later. And this where we said everything that worked for security up till now for the CIA triad, where we held someone accountable with a key, with a authentication token, and it tracks back to a person, starts really breaking down. Because we're not talking about a dozen services. You're talking about a dozen services being touched by 1,000 virtual machines, by hundreds of other applications in the world. And we give in a transition from SOAP to API. Who remembers SOAP? Yeah, I got a lot of old people in the room, like me. It's true. Not soap what you wash with for young people. It was a way you talked to the service-oriented architecture. And around that time, we realized, hey, wait a minute, all this ClickOps we're doing, all this like configuration by hand sucks. What if we just wrote down declared infrastructure state configurations, store it as code, and then say, hey, this is the state we want, make this happen. That was way too long to say, so we just started saying infrastructure as code. And we get Terraform, Plumi, CloudFormation, all the other awesome stuff that exists out there. And that said, hey, you can go from one server to 48 servers with one config change. But that also meant that you could do the same mistake once and it propagate literally everywhere across all of those machines. Because that you should never just allow that, by the way. Well, around all this time, and I know this is a little out of order, a little disjointed, but it's hard to tell the history of DevOps without spending 3 days doing it. We got containers. We said, why are we running an entire logical machine inside the physical machine? What if we just chopped up the OS into logical components that could supply just enough resources to run an application piece? We'll just call that containers, like the container ship. That makes way more sense than clouds to me. And we did. And then Kubernetes won a few years later. It's actually one right now, where it's like 88% of all cloud infrastructure in the world right now is Kubernetes based, which is insane to me, but there we are. But Kubernetes has things like, that's the actual control for security context, run as non-root. If you're in a hurry as a developer, what's the right answer there? 3, 2, 1. That's correct. No, it's not. See, even me. All right, but this is clearly where we hit the era of cattle. You no longer have Zeus or Teltran 3. You have zone, logical application breakdown, worker node, worker number, sub-process, giant strings that have 15 dots in them. And we're clearly in the era of cattle that we're herding along. And what do you do when a cow gets sick in the herd? You shoot it in the head. That's right. I've never had anyone not. First time I ever gave this talk, someone in the front row just did this. And I said, don't ever do that again, dude. That was terrifying. Like, never do that to a speaker. Didn't say anything. It was a wild look in his eyes. But we've known this for thousands of years, literally. This is on a pyramid somewhere. You kill cows. Like, that's what you do with them. This is what pets to cattle meant. Care for it, love it, keep it alive versus, it's disposable, just replace it. And then this thing came along. Now, I love ChatGPT. I love AI. For one, welcome our AI overlords. I just don't want my ChatGPT to have access to anything that I own. I like it to have a nice tight little interface that I can type things to, and it types me messages back, and then I can do whatever I want with that. I like that. But that's not the world we have inherited. That's not the world we built. That's not the world we're building. Instead, we gave it a wallet with actual access to real world stuff and a computer of its own that can do all sorts of logical stuff like Monte Carlo simulations and talk to other agents and other GPTs and other transformers out in the world. Now, for anybody that ever says, hey, I'm scared of the AI future, this is what I want you to tell them. Like, you're scared of math? That's it. AI is just math under the covers. One of the best talks I've ever seen about this is from Ira Winkler. There's a link to it in the speaker notes. So if you download the slides, again, I told you to get the slides. I'll show it again at the end so you can get them. And I'll happily share with you offline later. AI is just doing summation math at scale really fast on processors that did not exist 10 years ago. Summation math is, if you're not familiar with summations, that's cool. This just says loop through 5 times, increment up 1 per loop, and then do summation, so AK plus AK1 plus AK2 plus AK3 plus AK4 plus AK5. Whatever that is, whatever that means in that equation, in that loop. And what you do with that is you put it against giant data sets, and then you start factoring like these 2 things are closer than these 2 things in this giant grid, in this giant matrix. And that's called vectorization, and that is what AI is doing under the covers. So if anybody says, well, I am scared of AI, just say you're scared of factorization, you're scared of math. Now, what people do with math is build bombs. So you realize that's why Archimedes was paid, right? Like, he wasn't just a mathematician. He was getting paid by the kings to figure out how to get artillery to blow things up and knock down walls so they could invade and win. ENIAC was built to drop bombs, literally. It's how you use the math, not the math itself that should be scaring you. Anyway, to get off that tangent, all of these bits of math, these probabilistic engines that we hooked up to data sets to do vectorization, have clever, wonderful names. Claude, Mistral, Meta, Dolly. What wonderful names. But in our brains, this does something. For whatever reason, because it's a short, simple, we can pronounce it, we know what it means, we anthropomorphize it. We think that means it's human-like. Especially when we give it the ability to take action. You can knock off the word AI, and this is still true. It's a system that can pursue goals by taking actions on its own. AI is just the random number generator in the middle that says these 2 things are closely related, that's what I should do next, a billion times a second. That's where our water's going. That's why we keep building data centers. That's why your electricity is expensive. So we want to do that math really, really, really fast. So again, anybody that says, I am scared of AI, show them a picture like this. It's like, you're scared of web architecture? Where's the scary part? Is it the magic box in the middle that just does the mathemation really quick? We have been securing this for 30 years. We should know exactly where to put the guardrails. This is OpenClaw. This is a logical representation of the OpenClaw product. The magic of OpenClaw, which is kind of magical, is this gateway in the middle. This awesome gateway that sits right there, and everything's recursively through it. Like your brain's recursive, everything's recursive through the gateway. Where's a good place to put control points in OpenClaw? Going into or out of the gateway? Yes, that's correct. In fact, the thing we were looking over right, I know it's really hard to read, but that's directly copy-paste from the documentation for Claude, Claude Cowork. That's the hook system. It's there. You can just go put your guardrails anywhere you want inside of OpenClaw because it's not a thing. It's not a one unit. It's a logical set of web application pieces that we know how to build, that we have built, that you can put things, controls in the right place. All right. That's a long way to go to get to the point for the rest of this talk. Thank you very much for that. I got about 20 minutes left, right? Yep. So, all right. Hopefully you understand that by now, all of these are the same thing. They're just abstractions of the same idea of executing math, of executing ones and zeros against memory. Just this one can do it really, really, really fast down the bottom right. The thing that I'm concerned about above everything else in the world of security is access. Without access, the rest of the CIA triad just takes care of itself. It's that middle piece. Like if no one can get to your system, they can't affect it. If no one can get to the messages, they can't mess with the integrity. If they can't get to it, they can't affect availability. The access is what gives the attackers power. It's what gives us power as well. For human beings, we said, hey, we will give you a key. If you do something wrong, we will take that key away. And if you do something really wrong, we'll throw you in jail. If you do something really, really wrong, well, you'll become a trillionaire, apparently. But apparently, but I've been having this conversation for a long time about non-humans not being human, and they shouldn't have the same keys. And it's been met with blah. We keep giving an API key to the machine because it's the easy way to do it. It works. It's scalable. It's not safe, but hey, that's how we've been doing it. We've always done it that way, is the death knell of any organization. And that's what I've been hearing for years now in the non-human identity space. But now we're starting to reach this point where the general audience, the execs, the non-security people, the non-identity nerds, are starting to realize, like, wait a minute, we shouldn't give Claude unlimited, unfettered access. All the horrible stories of Mistral or whatever tool completely deleted my database in 9 seconds and all the backups. We shouldn't just have that free access. We're starting to hear these stories like, yeah, you're right. We shouldn't give AI standing permissions. We shouldn't give it human-like keys because you can't punish it. What are you going to do, turn it off? But wait a minute. If you shouldn't give a non-human with a name that's easy to pronounce any kind of standing access, then why on earth have we given standing access to all of the other non-humans that we have been building for the last 40 years? We have this golden moment right now to use the fear, uncertainty, and doubt of agents shouldn't have unfettered, permanent standing privilege to our advantage, to have the conversation of say, you're absolutely right. We need to have a handle on agentic and therefore non-human identity at scale. So here's the numbers to back me up. I hate secrets. Not like, I don't want to know your deepest, darkest secrets or anything. I hate things that grant access just for being a thing. API keys, classic example, certs. The way that Ev from Teleport defines it, the CEO of Teleport, a piece of data that by itself grants access. That's what a secret means. That's what I'm defining secret as. Credential, yes, there are subtle differences between a key and a database URL connection string with a token and a cert, but they all do the same thing. So I told you to get Guardian to come up. This is for a prize. We're going to play a fun game. We put out the State of Secret Sprawl report every year. And the way we do this is we look at every new commit that hits GitHub public. And we scan it for a secret. You can too if you really want. It's api.github.com/events. It's the feed. It's literally public. It's in the name. And you can just look at it. Say, hey, has this got a secret in it? Has this got anything valuable in it? And people do this all over the world. We send people emails right then and there if we find a secret. We're the good guys. But we put out this report every year based on what we found. So if you've read this report or if you've seen the slides and you've read ahead, do not answer. But for everybody else, I have prizes. And if you have read ahead, come up later, I have more of these. There's a tabletop exercise I made for finding secrets in plain text. How many secrets do you think we found on GitHub Public added in the year 2025? Just the year 2025, not cumulative. 7,000. 7 million. A billion? to put it in perspective, there were 1.93 billion commits last year in 2025 in the period we watched. Sorry.
28 million?
20, I can't tell if you read the report or not because it was 28.64 million. So you get a prize, and whoever said 10 million gets a prize. Come up here later and get them. I'm not going to throw them. Again, I don't know who said that, but good job for cheating. Good job for hacking at a hacking event, sir. I actually do appreciate that. This is terrifying to me. This doesn't keep me up at night anymore because I wouldn't be able to function by just not sleeping every night. 1.94 billion commits. 5.6% of them contained a hard-coded secret. Or the repo did anyway, not the commit, the repo. This has been going on for years, and it's growing since 2021 by our math, 152%. Meanwhile, population growth of developers only grew by 98%. This isn't just a new person problem. This isn't just a new training problem. This is an ingrained problem with the industry. Here's the kicker. We validate any secret we find if we can, do a non-intrusive call, this is key work. And we took a set of valid secrets from 2021, from our 2021 data, which is 2020 data, and ran the same tests on those valid secrets at the beginning of 2026, and 64% came back as valid.
That's crazy.
Yeah, we think so too. This is after many emails. Claude's not making it better yet. It's this interesting trend line. I'm just putting this in here just for more conversation later, but it's trending down toward maybe AI is actually going to help us fix this and give us better security. But I don't know. The jury's still out. Over the course of last year, it didn't made it worse. But then the trend line started edging back down toward normal. I'll pick that up later. And the tendency has been forever to just, hey, we got secrets, we'll put them in vaults. And that's a great step. I'm not saying don't do that. Please, please, please don't have plain text secrets anywhere. If you can see it in plain text, so can everyone else, including all the info stealers. Put it in a vault, put it somewhere safe. But if you work in an enterprise, if you work at a large organization of any kind, you have multiple vaults. And then it gets really confusing real fast on what does what. And then you get the role of secrets or vault sprawl on top of secret sprawl. And this is just a mess. So for the last 10 minutes I have, believe, yes, 10, 12, 15. Oh, wow, we can take my time on this one. What do we do instead? This is the whole point of this talk, to get to here. But I really do feel I had to explain everything else to make this make sense. Because I've been trying to have just this last part of the conversation for the better part of 2.5 years now. And it's not until I explain the pets to cattle part and the agent part that people start actually taking this part seriously for some reason. Not you in this room, but in general. There's this thing that we gave the ChatGPT that is kind of really, really, really important. When we give it a wallet, that wallet has to go to something. And what do we tie the wallet to? An identity. By the way, almost all the pictures that aren't corporate logos come from Wikimedia Commons. Thank you very much, open source. Thank you very much, public domain. So somebody named Jeff put his actual thing up there. License, driver's license on the internet. Thank you. We can move to a world, and this isn't the future. This is like literally how a lot of people are doing this, and this is literally should be the common way we do it, where we think of access as being, we can prove you are you, and we can prove you should be here and allowed to do that. That's what we should be building. So when security teams are talking to developers, we should say, hey, how are we moving toward identity-based authentication? And they might not know what you're talking about. We'll get into the details and nitty-gritty and actual technology names in a second. But if part of the bane of your existence is, hey, they got access by just picking up this key that exists, then this is the way out of this. Because this isn't a hard concept to understand from a very high level. Can you prove that thing is that thing, that it should be here, and that it should be able to do those things? These are very straightforward questions. Here's what I'm going to talk about for the rest of this talk. I'm not going to get into the weeds on all of this, I don't think, but people tell me I'm too technical sometimes, but I don't think I will be for y'all. We're going to start with something called SPIFFE, a universal identity control plane for distributed systems. This has been around for going on 9 years now. SPIFFE stands for the Secure Production Identity Framework for Everyone. Raise your hand if you know what SPIFFE, if you've heard of that before today. I dream of a day when every hand goes up, it's like, okay, just skip this part, we already got this. But this hasn't matured enough yet. This comes out of actually the work of Google from 12 years ago. Google does not use API keys for their internal servers. The concept's not even there. They have this idea that we're going to give everything an identity, and that identity will be used to broker access. Not to grant access, but to broker, to do some kind of handshake where this thing should be here. But it was expected, and here's the things it's allowed to do, let's go ahead and allow it to do it. Spire is the runtime environment that's open source and free. I'll get to a couple case studies a little bit later that go into a little of the meat of how to do this, but real quick, real simple, very high level. Everything when it's born should be issued a cryptographically provable ID. An X509, a JWT, something, but it's short-lived. 5 minutes, 10 minutes, maybe a day. It's like this, while it holds this, we know this is that thing. It can take that ID anywhere that will accept that ID and say, hey, I need to prove I'm me real quick. Trust boundary, the authentication, the authenticator, does a phone home to whoever issued it, to the certificate authority, to the SPIFFE, or to the Spire certificate authority, and says, hey, is this real? They do the cryptographic handshake because it supplies a public key. It says, yep, that checks out. That's the right public key. That's that. Okay. Then the conversation becomes, hey, we were expecting you. What do you want to do? And if it says, hey, I want to dump all the users, it's like, well, that's not something you're supposed to be able to do. So no. That's the world we can build with SPIFFE. And yeah, it's pretty low level. Yes, it does take some code changes. But like again, I said, this is a going on 9-year-old technology, 8-9-year-old technology. There's a great book. I'd recommend a lot of books, but this is the one to read if you read nothing else I recommended today. 198 pages that will change your life. And your developers that complain, I live in the world of permission hell. You can give them 5 hours back a week. Every bug that gets open because they leaked a secret goes away. All of the problems of that role got stale. It's still a problem, but it's way easier to solve because you're not worried about where the key lives and what needed rotated and who else had access to it. The keys just go away. Well, they get obfuscated to a level that they're not granting access, they're granting identity proof. And if you're like, I don't read a whole book, one of the best talks I've ever seen on this was the Cloud Native Security Con 2024. Again, the link to that, I know it's a long, weird link, but the link to that is in the show notes. Highly recommend it. They specifically told the AI not to use Disney property for the pictures, so that is not Disney property. They couldn't get sued because they told the AI not to do it. And you're like, well, that sounds futuristic and weird. How hard is that to implement? Well, if you're a Kubernetes user, if your developers are using Kubernetes, go have this conversation with them because for the last year, they've been able to do this for image pulls. It's built in, it's baked into the standard. You can just do it. You can just use it. I won't get into how exactly, but it's OIDC at the core. That's the whole reason I show this. OpenID Connect is not new. It's not hard to figure out. And it's more widely accepted than you think. And you're thinking, okay, yeah, but I cannot convince my dev team to refactor our code, and we have millions of lines of legacy code. Don't worry, Cloud Native got you on that. They built something called Istio. Now, it was using something called Envoy, but they've actually not abandoned that, it's still there, but they've recently gone to another protocol called Z-Tunnel. and moved from a sidecar where you need to run a container to do all this to ambient that just runs natively inside of Kubernetes. And what this does is it intercepts all the ingress and egress traffic, and then just handles that entire control plane of, hey, we can prove anything that's coming out of this container is this thing. Anything coming in to make a request to this had better be able to answer who are you and what do you want to do. It just handles that at a control plane level. It takes some config, sure, but it works at scale. It scales very, 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 very big to thousands and thousands of workers. Again, your devs are completely absolved from permissions, from keys. That's pushed to the control plane level and config. And I hear you. You're not completely cloud native. I hear you. I just spoke at Kubernetes developer conference, our Kubernetes community day, and I get it. Not everybody's drank the Kool-Aid. But this is the way the future is going. The IETF, the Internet Engineering Task Force, the people that make the standards, like, like TCP, HTTP, all of that stuff that makes the internet work, they're working on this called WIMSI, Workload Identity in Multi-System Environments. It's one of many standards that are coming out, but it is everything I just explained with Spiffy at scale for every workload, where the definition of workload is simply a workload as a running instance of software executing for a specific purpose. Yeah. There's a day in the not too distant future where it will be silly to think that you gave a workload a password. It'll be downright silly that you're still minting API keys. The same way that you don't have a host, what's the host list? The old text list that you had to host file. You don't have a host file that you have to manually update. Now we have DNS. It's that's how the internet works now. We're not that far away from this being standard. We're on draft 5 right now, and the last version looks pretty rock solid. It just needs wider adoption and wider sign off. But here's the best part about that. The future's already here. We don't have to wait for IETF to stamp something. Guess what? They're just describing the reality that's already being built by the cloud providers, by every other company on earth right now. Every platform on earth offers workload identity federation at scale right now. The one I'm going to talk about, the one that if you're an AWS shop or not, this is the one you need to go have a conversation with your team about. Azure can do this now, Google can do this now, but AWS did it, and they did it well on their documentation and their public media about it, at least in my opinion. But it was an AWS reInvent last year that they dropped this in November, but it's been available since August, as far as I can tell. So there's this thing they have called STS, Amazon Security Token Service, which does that whole, it's a service that issues identity to anything inside the AWS ecosystem. And it's been around forever, and you can use it within AWS to do identity, workload identity authentication across anything inside of AWS. Well, the thing that changed, it's now federated, meaning you can take that token it issues to anywhere else in the world that takes OIDC. So you can take it to Azure, you can take it to Google Cloud, you can take it to anywhere else, Databricks, name a very large company, they probably have this working already, not in theory, but in production. And say, hey, I got this token and I need to do this thing on Azure and I need to assume these roles. Do the phone home to AWS. Hey, STS, is this thing real? That's real? Cool. Hey, we were expecting you and we said if you showed up and we could prove you're you, then you're allowed to consume this role within our service and you can do that one specific thing. You're trying to dump user database? No, you're not supposed to do that. You're not allowed to do that. That's not allowed to happen. Now we're back in role land. It doesn't solve authorization. We're solving authentication here. This is what it looks like in code. Pretty straightforward. It's called STS and use that token. Here's the kicker. This is free. It works on everything inside of AWS. Google's is free and it works on everything inside of Google. Azure's is free and it works on everything inside of Azure. The future is already here. It's just not evenly distributed. I give this talk a lot. I give talks like it a lot. And I always get to this point, and I know this is very technical, it's in the weeds, but this is exciting to me. The better alternative is freely available. It's the same problem that I have being a Linux daily driver desktop user at home. It's like, we've been building tanks for years that are awesome and scalable, and they do great stuff, and they're free, and nobody will listen to us. Please, I'm begging you, go have this conversation with your dev team, the heads of development, like, hey, why aren't we moving toward federated workload identity? And they better have an answer for you. And if we're like, well, we can't do this on our own, like, that's gonna take some serious platform engineering. That's when vendors actually are kind of cool. There's a bunch of players out there that you probably already have relationships with. I like Teleport, I like Ambit. I didn't put Ambit up here for some reason, I don't remember why. HashiCorp, Achilles, CyberArk. There's probably a PAM provider you already have, that you already trust, you already have a contract with, that would love to have this conversation with your DevSecOps teams. I would love to have a conversation with your dev teams about how do we get you toward identity-based workload authentication. We have a solution for that, and for right now, it's completely free because we just want everybody on it. I'm not saying we provide you the best possible, but we're moving to a world standard where, since it's OIDC based, you'll be able to just move from one service to another as you need. But as my friend Josh says, open standards don't mean vendor lock-in in the way that you can freely jump vendor to vendor. It means you get the best of all possible worlds. You're not locked into just that vendor. Now you can take things from Azure, even though you're an AWS shop. Now you can take AWS, even though you're an Azure shop. Other way. Whole point here, and if you take nothing else away, read the Spiffy book. If you take two things away, next time someone says, hey, this agent shouldn't have this access, agree with them violently. You're absolutely right. We should not give an API key to an agent. Also, we probably shouldn't give API access to anything that's not a human. We shouldn't give keys to things that aren't people. We can't hold them responsible. We can't hold them accountable. A couple last shout outs, and then I'm going to close it. I'm happy to have many conversations in the hallway the rest of the day. I'll be around for happy hour. But what do we do in the meantime? Because honestly, yes, you can't move everything to workload identity-based authentication right this second, especially in a world where we're building agents on our laptops as fast as we can. And we still have this world of API keys we have to deal with, and SaaS providers that will not stop issuing them for some stupid reason. But in the meantime, what do? Vaulting is the next best thing we have. I have nothing to do with this company. I just really, really, really like this model. And I really, really like this open source tool. It's free, agentic mini. It abstracts all your access codes, all your access mechanisms, API keys into a local vault, and then handles blindly agent calls. The agent never sees, it can't get to agentic. It can't get to this implementation layer, this execution layer. The call goes to it. It intercepts just like Istio does. That's where the idea came from. It takes that control plane and says, okay, here's the access we're going to broker. Now the call can go out. When it comes back, it strips out anything that would have been a call or an API key or whatnot and goes back to the agent. It's all open source. You can dig through the code yourself. We're like, okay, but who's doing this at scale? This is my favorite paper that any internal production team has written, maybe in my entire life. I got excited. I jumped up and down when I read this for the first time because I saw them these guys give this talk back at KubeCon last year. And I didn't fully understand the extent that they were building this until they released the paper. Because for anybody that's actually dealing with production, large-scale systems in the world, you're thinking, okay, this idea of identity brokerage is great and all, but what's the overhead on that? 40 milliseconds. That's the answer. And you can dig through this paper to see exactly what that means. But a company the size of Uber has agents running everywhere. None of them have API keys. And now Uber can track every single call. Full auditability on every single hop. Agent 1 talks to Agent 2, deep within the stack, full auditability. This is how they built it. This is their golden moment. Use the fear, uncertainty, and doubt that we shouldn't give this stupid thing key to remind them that we shouldn't have ever given anything that's not a human a key. But I'm Dwayne, came from Chicago. Sorry, a little over time, but check out my website, see where else I'm going to be speaking, and hit me up on LinkedIn. And there's the links again for getting these slides. Thanks very much.
All right.
Thank you very much for giving me that.
All right. Thank you, Dwayne, and then also a reminder to everyone in the mentor area in Alcac, they're giving away T-shirts from last year.
Yes.
So if anyone's interested in